Gonna just give it a few more seconds for, and happy Wednesday, everyone. Thank you so much for being here today for our code webinar. For those of you who attend our webinars regularly, you know that our normal moderator, Mike Collignan, who does a fantastic job, he's not here today. He's not available. So you're stuck with me. I'm Sarah Gutterman. I'm the CEO and co-founder of Green Builder Media. I'm really happy to be here today to talk about one of the most critical topics in our industry, codes and evolving codes. Today's webinar will focus on the compliance paths, key changes, and implementation of the residential section of the 2021 IECC. After providing an overview of the 2021 IECC for residential buildings, we will review the findings from the Department of Energy's residential field study to address where industry professionals and homeowners should focus for maximum energy savings and energy cost savings. And here with us is Shaunna Mozingo, president of the Mozingo Code Group. In addition to being a plans analyst and inspector for jurisdictions, Shaunna has provided code adoption assistance to many jurisdictions in the US and beyond, as well as research and training services on energy code topics. And she's also authored multiple books in her spare time. She has won numerous code-related awards, including the Department of Energy's prestigious Jeffrey A. Johnson Award for Excellence in the Advancement of Building Energy Codes and Performance, IECC and IMT's Standard Bearers Awards, and the Southwest Energy Efficiency Project's Leadership in Energy Codes Awards. We're really lucky to have her here with us today because she is one of the industry's preeminent codes experts. But before I pass things over to you, Shaunna, I first have to thank our sponsor, PowerShift by NV Energy. The PowerShift program helps residential and business customers conserve energy and save money on their power bills. PowerShift is a one-stop resource to find energy-efficient products and services. For more information, please visit nvenergy.com/PowerShift. Now, one more thing, during the course of today's presentation, we encourage you to please submit questions, and you can do so in the questions box on the right side of your screen. I will review those questions and pose them to Shaunna during the Q&A session set aside at the end of her presentation. So Shaunna, it's good to see you again. Please take it away.
All right, well, thanks. Thanks for the intro. Thanks for allowing me to be here today to talk codes. One of the more fun things I get to do in life. All right, I think you have already learned enough about me. I am a code official from at heart, but I also have my own business, Mozingo Code Group. Like she said, that help people adopt codes, amend codes, write their codes, learn their codes, and figure out where we can go next. They do a lot of research studies for the Department of Energy or utility companies or states. And so the second half of what we're going to hear today is the findings of the research study that we did in Nevada a couple of years ago, actually. Then COVID hit and kind of things took a standstill. So we're just now finally got the results from PNNL. So we're going to share those with you a little bit. But so enough about me. Let's talk about the codes. So we said in the beginning that we were going to talk about the pathways of compliance, and this is one thing that I hope everybody will really hear. We're going to go through just a high-level overview of what's coming in the 2021 to be aware of. But one thing that hasn't changed in a while are these paths of compliance. One thing that I get a lot of is frustration over what they think they have to do in the code. And so a lot of people open that code book to that original R value table in the IECC and be like, you want me to do what? And start getting really angry. And so I would just encourage everybody to just turn the page. There are a lot of pathways through the code. In fact, in chapter 1, the very first thing that the code tells us under the intent is that we have to provide flexibility. It's right in it's written in there that not only we write this book to conserve energy, but the way that we do that, we have to provide flexibility. We have to provide options. We have to not do anything to hinder technology or advancements and those kinds of things. So in the process of trying to provide flexibility, we have a lot of different different ways through the codes, a lot of different paths of compliance. So you have the prescriptive compliance path. That's just like, tell me what I have to do and that's what I'll do. And that's the one that I think most people look at and freak out about, because there's not very many trades built into that. There's not a lot of things that you can do in that. You just have to do what the tables tell you and what the code tells you. And so that's where you're going to find a lot more of your costs because you're not trading things off. And so while a lot of people like that path because they just want to be told what they have to do, they also don't like it because it does cost more sometimes. And so I would encourage you to explore some of these other paths of compliance. So prescriptively, you have an R value method. That's the R value table. Do what I put in those R values of insulation, and we'll look at those in a minute. There's a U factor method, which is the same prescriptive table as that R value. It's just everything is in a U factor. And so the difference between the R value method and the U factor method is that the R value method gives you just the rated R value of the insulation, where the U factor method takes into consideration every single layer of the building assembly for a total U factor of the assembly, not just of the insulation. And so a lot of people look at those tables and don't think that they are equal, but they are, and we'll look at that in just a second. Then you have the total UA alternative. This is also U factor, but it's a U factor for the total U factor for the entire area of your thermal envelope. So it's looking at the U factor of the roof assembly or ceiling assembly, the walls, anything that's involved in the thermal envelope, the area of that times the U factor. That most people associate that with res check. However, some other paths can also do a UA calculation, and so the code never uses proprietary names like res check or com check or things like that. So, but that's what most people associate the total UA alternative with, because that's what res check is evaluating. There's total building performance. We'll look at that. That's based on cost. How much does a building cost in annual energy use? And then energy rating index, which is ERI, which some people associate with like a HERS score, or it's using a score, an ERI score for compliance. And so there's a lot of different ways to comply. The further you go down into performance and ERI, the more trade you can have. The higher you stay at the top, prescriptive, the less trade you have. But it's easy. Just tell me what I have to do, and that's what I'll do. And so depends on who you are and which path you like. So we're going to talk more in detail on those. What I want to give you right now is this high level. Here's what's coming in the 2021 that you really need to pay attention to. This is for residential, and it affects every climate zone out there. We'll look at some more of these in more detail like this. There's now options in that R value table. There are options for a cavity only option, a continuous only option, and a cavity plus continuous. I don't see people doing all of those, some of those because the numbers get pretty high, but they are options, and trying to stick with that intent that we have to provide flexibility and options. That's what this table now does. If you are used to the options maybe in climate zone 5 that I can remember right off the top of my head were R20 or 13 plus 5. Well, that's an R20 cavity or a 13 plus 5 for cavity plus continuous, and now you have a cavity, a continuous. You also have a continuous only option. So if you wanted to only do continuous insulation, which hasn't ever been in there. So the U factors and the solar heat gain coefficients, I'll tell you, did go up a little bit in some of the climate zones. Now, if you're tuning in from Nevada today, Nevada has a few different climate zones. And so some of them did go up. And if you're in northern Nevada, that is definitely, you want to pay attention to that U factor table, because there's a new footnote in there that once you get over 4,000 feet in elevation, your U factor drops. In the table, it'll say like 0.3. We'll look at it in a second. It'll say like 0.30, but if you read the footnote, it'll allow you to go all the way up to a 0.32, because once you get over elevation, if you're relying on that gas fill to get those good U factors, that gas, you lose that the higher in elevation that you go. So some of those kind of things are now being recognized in the code. Air leakage testing has some changes in it. It's mostly looking at the changes in the fact that we used to have like a set 3 air changes per hour in most of our climate zones. That is still in there, and you have to really pay attention to how this code is written, because when you first read it, the way they laid it out, it looks like we're allowed to do 5 air changes per hour. But if you read all the way to the bottom of that section, it does say that 3 air changes is really the requirement. You can trade off though. So you can trade off up to 5 air changes per hour. So if you use a performance path, like the performance or the ERI path, you can trade off that air leakage amount, but only up to 5 air changes per hour. But if you go prescriptively, that amount is still 3 air changes per hour. So there's some things in there. So there's also some nice changes brought in to recognize those smaller units for attached housing or smaller homes that couldn't get an air change per hour, because that relies, the more volume you have, the easier it is to get those air changes. So the smaller houses were really having a hard time complying, or those apartment units. And so it brought in the allowance for a different mechanism for testing. You can test to the CFM, or per square foot, so of area, and so that's a lot easier to meet when you're doing testing in a smaller home. So those just some new things coming in for attached housing, some exemptions in there for attached garages that are conditioned on when you test and when you don't. So some things to look at there. One thing that I want to bring your attention to is the duct leakage testing for the 2021. The biggest change there is they removed an exception, and so that is a very big exception. It used to say that you don't have to do a duct test if your ducts are in conditioned space. So it gave you all of the requirements for duct testing, and then it had an exception, except ducts inside the envelope. That didn't have to be tested. Now they removed that exception. So all ducts have to be tested that are part of the heating and air conditioning system, have to be tested even if they're inside the thermal envelope. So that is a big change for the 2021. And it's, you don't catch it until you realize that that exception is gone. So pay attention to that. There are some more efficient mechanical things in there. They updated the efficiencies of like the kitchen hoods and those kinds of things that might be a part of a mechanical ventilation system if you use those. So some things like that have been updated. There is an addition to the lighting section. If you've been involved in the energy code for very long, you realize that IECC lighting section has been one paragraph for a long time. It used to be, 50% of the lights have to be high efficacy, and then it went to 75, and then it went to 90. Not only is it now 100% of the lights are high efficient, but they also brought in lighting controls for residential. So you're going to have some cases, not everywhere, but some cases where you're going to need either dimmers or timers or occupancy sensors or something now for indoor and outdoor lighting requirement for controls. So that's the first time that we've had lighting controls in residential. They brought in the addition of additional energy efficiency packages. We've had them in commercial since 2012, but this is the first time in residential, and so we're going to take a look at that so I can explain it better. And then there's a new appendix for net zero ready for those jurisdictions that want to have a way to get to zero over time. There's an appendix now that allows you to do that. You could adopt it and people can get to zero over time using an ERI score. So those are the big changes. A couple that I want to highlight. When I talk about this cavity only, continuous only, or cavity plus continuous, when you first look at the code, if you bought the first edition, it didn't have them in there. So don't forget that they make the code, they write it, we start using it, and we find errors, right? And so there is errata. You need to go to Errata Central. If you just Google Errata Central, ERRATA Central, you'll get ICC's errata, and then when you go in there, you click which code you want the errata for, and you can download all of the errata. Because you will see that when they first printed it, in black is what they printed, which gave us still that 20 plus 5 or the 13 plus 10. It only gave us those two options. That is not what is required in the code. What's in red, all of this is what's required in the code. So make sure that you really download those. So you have, like in Climate Zone 5, you have an R30. If I want to do cavity only, it has to be R30 prescriptively. This is on this page. I would encourage you to turn the page and go a different path if you don't want to do these things. So R30 continuous, R20 plus 5 if you want to do a cavity plus continuous in like in a 2x6 like cavity, or a 13 plus 10, or an R20 if you just want to do only continuous. So you see you have a lot of options in there for those climate zones. I think, so we have a climate zone 3 in Nevada, and we have 5 and 6. So just make sure that you're paying attention to those climate zones and how to read that. Every one will have a cavity only, cavity plus continuous, and a continuous only. So pay attention to that and download the errata. There's so many for the energy code. And then, so those are your climate zones. That's that R value table. You have to do everything. It does give you some U factors in there because we have to talk about windows. You'll see that you're at a 0.30 across the board, but you see in climate zone 5 and higher, you're going to have this footnote I, that if you look at the footnotes, that's where it's talking about. If you're in wind-borne debris regions where there's hurricanes or other things, or you're in a high altitude, that U factor changes. So pay attention to those. There's a first time ever that solar heat gain came into climate zone 5. So pay attention to that. But you'll notice some changes in here of the ceiling R values went up in almost every climate zone. The wall R values went up, so there are some changes to be had for sure. Then if you're in the U factor table, which is this is the U factor of every layer of the assembly. These two tables are you can use simultaneously. So if I say, you know, I'm okay doing all of this, I just don't like any of these options. I can do everything in this table and then go to this other table and just do the that was a wood frame wall. So a 0.45 or a 0.060 or a 0.04. I just have to meet this U factor. That's mean I have to add up all the layers of the assembly and still stay under this U factor. So you could do that and you might be able to comply. You could do that with several of them. You could do that with every component and just calculate your own U factors and make sure you stay under them. It's allowed. It is a pathway. I just never see anybody use it because if you're going to do all these assemblies, you could just go over to the total UA path and do that and use ResCheck or one of the performance softwares that does a UA calculation, and it'll do it for you. But if you just wanted to do one or two of those, you could interchange the two tables and just do one or two of them. How do you find the U factor for material? ASHRAE Handbook of Fundamentals has it. What I use is ASHRAE 90.1 because I have ASHRAE 90.1 that I use when I'm reviewing for commercial buildings. And in it, in Appendix A, there is a table in there for every different kind of assembly with insulation or without, and it gives the total assembly U factor, so I can do that. Or I sometimes, if I just have one thing I want to look up, I will go into res check and just put an assembly in there and get the U factor for it without building the whole building in res check. So there's a few different ways to figure the U factor, but if you're going to do it for the whole building, you might as well go over to this total UA path and use it. What this is doing is like a twin house concept. You have two houses side by side, and you're trying to decide what the U factor, overall U factor is. One house in the software, like ResCheck or other softwares, one house is built to that prescriptive U factor table. So based on how much window area and how much wall area you have X amount of U factor. It's a budget you have to stay under. So then you design it the way you want to, and as long as you stay equal to or under that budget, you're fine. You can build it that way. And so it allows you to trade some things off, but only things that can be converted to a U factor. So wood, insulation, glass, those kind of envelope items can be traded. You can't throw in a high efficient piece of equipment or a better duct leakage and trade that. You can only trade envelopes. So it is the first steps towards a trade-off path, but it's only trading off the envelope. I can put in a better insulation to get a worse window or vice versa, or I can put better insulation in my attic to get less insulation in my wall, or however you want to play with it to work it out. I call it my checkbook, the beginning of my checkbook. From total UA through all the performance are like checkbooks. I can do things above code that add a deposit into my account. I can do things that are below code that withdraw from my account. I just have to stay in the black, right? I can be at 0, but I can't be less than 0. And so that's how these trades are. I can do better than code some places and less than code some places. For the total UA, I can only do better or worse in envelope requirements, but in other paths, I can trade a lot more. So you just have to decide what path is best for you. And so the way this works is people think, okay, I have all this, I have wood in my building and that's great structurally, I have to have this, and so if I have 1 king stud is really good, 2 king studs got to be better, right? And so what about this? Am I super great structurally with all of this wood in my building? Well, maybe. I mean, it might be a bit overkill, but what you definitely are is worse in your U factor of your building. So what we're trying to get at less wood. And so if you see wood has about 1 R value per inch, whereas insulation is 3.5 to 7, depending on the type. So you could see without any continuous insulation, I can see all of the studs in this house. I can see that I'm going to get some thermal bridging. I'm going to get some loss there at all of those studs. So what this UA path and all of the other trade-off paths is trying to get us at is to cut down on some of that. And if I do, I can get out of something else, right? I'm not going to get out of it, but I can lessen the requirement. I probably will never find anything that I could totally do without. I won't be able to trade that far, but I could maybe put in a less of a window if I put continuous insulation on this house or something. So what we look at is if I have less wood, so maybe I'm doing some good framing, and I'm going to do 24 inches on center instead of 16 inches on center, then I have a better framing. I have less wood, which wood is so expensive right now anyway, so there's one savings, right? I have less wood, which I have less thermal bridging, so there's energy savings, and then I have more insulation, but because I have more quantity of insulation, I probably could drop down on the R value of the insulation and maybe be able to make that trade. So because I traded to less wood, I probably could trade down the R value on my insulation. So that's just kind of how this U factor and the performance paths work, is what are you willing to do better than code? You might be able to do less than code somewhere else. It doesn't mean I'm not putting insulation. I just might be able to, instead of an R20, I could put it in an R15 and still, because I'm using less wood, have just as good of a performing wall. Or what if I'm willing to put in continuous insulation? So now I don't have any of that thermal bridging, right? I don't see any of those studs. I don't have that. If I put continuous insulation, that gives a huge credit in the code. And so now I can really maybe put in lesser of a window, or I can maybe trade, well, in residential in the 2021, you can't trade slab edge insulation. But I could trade maybe, instead of R49 or R60 in my attic, I can get away with the 38 that I used to do, or whatever. There's just things that we can do in there to trade. And so that's what these paths are doing. This UA path, a lot of people are familiar with it. ResCheck is the simple software that we can use. Doesn't have to be ResCheck. That's just what people have associated with them. It's a free download at energycodes.gov. You just go in there and build your house, and tell it how you're going to do. Are you going to use a flat truss, or you're going to do a raised hill truss? A raised hill truss will give you a better credit, right? Because you're getting more insulation over the top of that wall. You're getting full height insulation. And so you get a better, you would get a better U factor than with this flat or ceiling scissor truss. And then you have, wood frame at 16 inches on center. And then what if I did it at 24 inches on center? You could play around with it, but you can get more trades and maybe do worse somewhere. So that's ResCheck. There's a lot of things in there that are beneficial, but again, it's only the thermal envelope. If you want to trade more, I would challenge you to get like an energy rater, a HERS rater, energy rater, and go performance. This is where you're going to see the most of your trade and actually be able to see how well your building is performing. It's a computer software. Again, that twin house concept. It's got the houses that are designed the same square footage and things, but one is configured to the 2021 prescriptive requirements. And the other one is whatever the designer is or builder owner wants to build to, and you input them into the software, and it's based on cost of annual energy use. So as long as you could show that the house you're proposing to build costs less or equal to the house built prescriptively in annual energy use. So you input the local energy rates into the software, and as long as you can say over the course of a year, I'm going to be equal to or less than this house if it was built to code, you could do the way you were proposing to do. So it offers a lot more trades. There's a couple softwares out there. Energy Gauge is used in Florida. RemRate was the one for a very long time, but now Ecotrope seems to be pulling ahead as I do some research. But they both will look at the performance. They both will look at ERI, and they both will look at total UA. So you could use that software for all of those pathways. And you could see that the reports are similar. You look, and it's looking at heating, cooling, and water heating costs. And as long as this is an old report, but you can see it evaluates many different code additions. And here's the cost if I built it prescriptively. The house that I'm proposing is only 945 instead of 1,008. I'm doing better, so then I can build it the way that I'm proposing to do. And that's from plans to proposed design, and then you go through and enter what you actually did in the field. There's some different things. It tells you how much better than code, tells you what addition you're doing it to. So when I teach the actual paths of compliance as just one class, I will go through and explain it more, but we have got a lot to get through. So that's one path. And then the ERI path. The ERI path is the Energy Rating Index. It's using a score for compliance. Same software, same people, same raters, everything. Looking at it, it's just instead of using that cost metric, or that cost metric also has an option for a BTU metric. This is using a score. A score of 0 would be a net zero energy use home. Score of 100 is the 2006 Energy Code, basically the 2004 supplement, but 2006 energy. So if I had a score of 85, I'm 15% better than the 2006, right? So I have to go through there and figure out what my score is. It gives you you look at a lot of the same things. There's more trades built into this. You look at a lot of the same things, but over the years, it came in and it gave you a set of scores you had to meet. The 2021 has lowered those. So, if I'm in climate zone 5, I have to get a score of 55. If I'm in climate zone 3, a 51. I think we're at 6, maybe in parts of Reno or up there, 54. I have to get a certain score or better. So the lower the score, the better. Of course, we're trying to get to 0. I have to get a certain score, and it tells me what score I have to get, but it allows much more trade than any other path. And it does allow you to use solar and some other things to lower the score. So it allows you to say, maybe I'm going to put in a high efficiency furnace that will lower my score. That's my deposit into that checking account. Or I'm going to use 100%, I don't know, high efficacy lighting is now required at 100%, so that trade might not mean as much. I could put all my ducts inside the envelope. That gives a really nice trade. And so I could put in high efficient, actually this one will give you a credit for high efficient dishwasher and washing machine and those kinds of things. So there are different things that I can do to lower my score then so that I could trade off somewhere else. It does allow you to use solar to lower your score, but it sets a limit at about 5% of that end energy use being allowed to be offset by solar. Each edition kind of changes that metric, but it is in there. It's buried in a paragraph somewhere in the code that gives you that 5% limit. It does require you to build a good envelope because if you're going to use solar, because solar can go away and we don't want to be stuck without a good envelope. But there's a lot of trade built in there, so that's how that path works. The 2021 additional efficiency package options is interesting to find how you get there. In R401, it tells you that you have to comply with 401.40125 and one of those paths. So it says if you go prescriptive, you have to go to 408.2 and pick one of the options to do on top of everything else that the prescriptive path tells you. If you go performance, you either pick one of these options or you do a 5% better than standard reference design, right? So, and if you're going to use a score, you have to we saw that table, that score that you have to get, you got to do 5% better than that if you choose ERI. So, but if you have to choose one of these, the options are to do a 5% better thermal envelope total UA, so get a res check that passes by at least 5%. A more efficient heating and cooling equipment, more efficient surface water heating equipment, a great duct system, and put all your ducts inside the thermal envelope, and it goes into some specifics on what that might be in the inclusion of ERVs or HRVs. And then, or build a tight house and do an ERV or an HRV. And so you have to choose one of those options. If you go prescriptive, if you go performance, you either choose one of these or do 5% better than the standard reference design. And then ERI, do 5% better than the score that's required. So that's a new requirement in the code. If you're used to it in commercial, you only had to do it if you went prescriptive. But in residential, it doesn't matter which path you do. You're going to have to do whatever the code tells you to for that path, plus go at least 5% better than that. So that's flexibility built in, believe it or not. That's instead of cranking the code down everywhere by 5%, they're giving you your choice of how to get that extra 5%. That's how that works. And then you had the inclusion of the other significant change was just the inclusion of those additional efficiency package options. So, I mean, the inclusion of the appendices. So you have a Board of Appeals. That's a new appendix in all the codes this in 2021. There were a lot of jurisdictions who didn't have a Board of Appeals, and they didn't even know how to start that. So he created this appendix. If you're a jurisdiction that doesn't already have policies and procedures for how a Board of Appeals would work, you could adopt this, and now you have it. If you want solar ready provisions, you can adopt Appendix RB, and if you want zero energy residential energy provisions, you could adopt RC. None of these are required unless a jurisdiction or a state specifically adopts them, then you would have to do them. So those are the big significant changes in 2021. I'm going to jump right quick now into our findings in the study. I think Les Lazarick, he helped with this study in Nevada. So Les and I did Nevada, and then Robbie Schwartz of Build Tank Inc. and I did Colorado. So Les and I did Nevada. We went and did this study and looked at the houses. I will tell you, we used a methodology that the Department of Energy has created a methodology so that everybody's doing it the same way, so that when we all turn in our results, they can analyze them and compare apples to apples. So you can find that methodology at energycodes.gov. That's the same website where you download ResCheck and ComCheck. You can go there and find the methodology for residential field studies. You can also Google residential field studies and you'll find it there. So what do we do to gather the data? That methodology tells us we can never go into a house more than one time. Well, you know that we can't see everything in one time, right? So we had to split it up. We had to see 63 of every measure. So in order to do that, we had to go to at least double that amount of houses. We had to do a certain amount of roughs and a certain amount of finals. So we did 63 roughs and 63 finals so that we could get 63 houses. So we 126 houses to get 63 houses. So we couldn't ever go into one more than once. We had a sample plan created from permit data. So we were able to get permit data from around the state. Where were all of the permits being had? Where was the construction taking place? So that we could at least choose those jurisdictions. The majority of the houses were in places where the majority of the construction was taking place. We did go outside of some of those areas to look at houses, but the majority was where the construction was taking place. The study is anonymous, so you will not know what builder we looked at or what house we looked at. Les and I know that, right? But nobody else knows that. The state doesn't know that. When we turn in the results, we scrub all of the information. The Department of Energy doesn't know any of that information, only Les and I. And so we scrub all the information. We want to keep it anonymous. That way you get statewide results, and nobody is no code official, no contractor, nobody can gain bias or say, oh, this contractor did bad, this one did great, or this is what this inspector looks at and this one doesn't, or nothing. We just want to go in there and gather data to get a baseline of where are we at, so that we can provide training and resources and then go look again in the future and say, oh, look, this has made a difference, or hey, we still need to do things here, or maybe we need to change the code because nobody's understanding it. Like, we're just trying to gather data, and if we start making it look like we're judging you or you guys can judge each other based on our results, nobody will ever let us in their buildings again, and we just never want that. So it's completely anonymous. Nobody knows what's going on. And the only reason that I collect the information is so that I know that I didn't go to the same builder more than once in a subdivision, and that I dispersed things out, that we didn't look at the same, all of the construction in one place in a town. We tried not to go to more than one house in any subdivision, no more than one builder in any subdivision. We really wanted a broad sample, and that's the only reason that I had that data. And then it's scrubbed and taken away. So I couldn't tell you right now, if you asked me how this builder did versus this builder, that information is gone from my brain. So we did have a mix of production and custom builders. Like I said, a mix of locations around every around the entire state, around each city or jurisdiction that we picked. DOE has a random sampler that they create. They take all of the jurisdiction construction data and they put it through a random sampler, and it spits out that sample plan that tells us how many buildings we have to get in each city and which cities we go to. So a lot of it is anonymous. We prioritize what we look at by DOE's top 8 items, like air leakage, duct leakage, insulation, those kind of things. We did look at a lot more than that, but we looked at a lot more than that, but those were our priorities to make sure that we might only have 10 or 15 of this measure here and this measure, but we have 63 of their top 8. And so that's how that's done. And we looked at different things like what paths of compliance did people use, what code edition did they look at, even though you have a state, sometimes there's state codes, different jurisdictions are allowing different additions we're finding. And we looked at what kind of equipment was installed. So we'll show you some of those findings. One thing I will say though, even though you have a Nevada amendments, we looked at everything compared to the 2018 IECC. What Nevada had decided to do was to look at, and Colorado did the same thing, to look at to the 2018 so that we could see how close are we already to the 18. So if we try to move to the 2021, we know how big of a step we have to take going to that 2021, because here we are compared to the 18, not compared to all of our amendments. So just keep that in mind. There is an amazing website that you can go to find all of this data on every residential study that's been done out there that uses DOE's methodology and uses PNNL to look at the results. So it's fun to go. We don't have time right now. In our future trainings that we are going to do in Nevada about our findings, we'll tell you what we found. We'll go to this, show you how to analyze the data. It gives you, here's where you rated according to the 18. If you did this, you would save $1 million over the course of a year, or you would save, 500,000 over the course of the year. It gives you great information in there and how you compare to other states and stuff. So I would encourage you to go play around with that. We will show that in our regular trainings that will be between 2 and 4 hours. Some will be in person and some will be virtual. So, but for now, I don't have time to go through that with you. I'll give you a summary of what we found. So when we looked in Nevada, this is Northern Nevada and Southern Nevada together, we found out of all of the houses that we looked at, we ended up looking at over 128 houses or 129 houses. One of them showed compliance with the 09 code, even though the 18 was adopted. 7 showed compliance with the 12. That means when we're looking at them, maybe they turned in a 2012 reg check, or they performance was done to the 12, or compliance was based on the documentation that we looked at. We were able to verify that those were the codes that they had showed compliance with. So that was interesting to see. Even though you're on the 18, a couple snuck through on a different code. Paths of compliance, when we looked at them, the majority of the houses did use the building performance. I would say, just having analyzed some of this data, that the majority of those performance paths were in Southern Nevada, because Northern Nevada, I found, were doing more prescriptive or res check. There were some performance in Northern Nevada, but the majority of these 71 were in Southern Nevada. Doesn't mean 26 actually went prescriptive. If we couldn't figure out what path you chose, we had to put you in as prescriptive. It doesn't necessarily mean that they all went prescriptive, but that's what we evaluated them to. So you had some that went ERI also, and then there were some that had a HERS score and chose that ERI path, but they had a HERS score. The average HERS score was 66. So that's good to know. If you look at that table and you know that in the 2021, if you went ERI, you'd have to have a 50 something. Okay, here's where I have to go, right? Now this is a HERS score and not an ERI score. They are a little bit different. they're coming more and more in line, but again, that's another class. 16 of the houses met Energy Star requirements, so that's cool. So those are just things, those are things that I tracked outside of what DOE asks us to track. So here's what DOE asks us to look at: air leakage, right? So we looked at all of those homes, the leakage testing results. The average was 3.7. So you could see there was some good houses all the way down to 1.5, but there were some outliers that all the way up to 7. So that just tells me if our average is 3.7 and the code requirement is 3, if I go prescriptive, I have some areas of training that I need to do on how to seal up that thermal envelope. And so that's great. That tells us where to go, how far we have to go. A couple little more things and you're there and you'll never have to worry about it for Nevada. So that makes me feel good. Some things I found: prescriptive compliance was struggled more than performance, because maybe when you go performance and you utilize those energy raters and they are doing a lot more of the on-site being there, you know, maybe looking at that air barrier when it's going up, or looking at that insulation when it's going up, or looking at things a little more closely because they might be able to be there a little bit more, or have a little more one-on-one conversations with the builders and interact with them a little bit more, then they can make sure that we are in better compliance. Production builders are more used to testing. Now, Nevada has some amendments in certain places out of the testing requirements, or a higher testing allowance. And so we did find that production builders that have to build everywhere, they're so used to testing in other places because it's required, that they were more used to testing than custom builders were. And those localized amendments bring the numbers up. So when you see some of these averages, remember there are places that don't require blower door testing because of amendments. And so we might have tested and they got up to 7, but they weren't required anyway. So it just raised your average. It doesn't mean you weren't meeting code because your code is amended. We're comparing to the 18 and it's just saying, here's where you are. If you want to go to blower door testing in the 2021 or go to blower door testing as a requirement at all, here's where you're at. And so we just have to pay attention to some of those details. But we found the problem areas: the bottom plates, the top plates, the drywall connections, just basically our thermal envelope connections and penetrations. So we're going to look at that in detail. Looking at that thermal envelope, it has to be defined. It's been required to be defined in the so that we know, is that attic inside the envelope, is a crawl space inside the envelope or outside? Where is your envelope? And let's get every detail of that sealed up tight, right? So that we save energy, we have a more durable and resilient building. And you know, we witnessed here in Colorado the less spread of smoke when houses were on fire and they had a tight envelope. Houses next door didn't get as much smoke damage. So there are all kinds of things, reasons that we do that. But why air in is air out. If I have leaks out of the building, my house is always going to keep a neutral pressure, and so it will bring air in from somewhere, and it'll bring with it anything that's out there. So and plus I have to reheat and recool that air. So what I just want to get to real quick, because you guys had some, you just have a little bit to go on this air tightness to meet that, to where you wouldn't have to worry about, oh, who cares if the code changes, because we're there already, right? And you almost are. We do those blower door tests to find the leaks. We want to go, we're not saying don't have any leaks, we're just saying don't go from so many, let's get a little fewer, right? And so the requirement is 3 ACH in all of the Nevada climate zones. You can trade it off, but you can't go over 5 air changes per hour. You can use that CFM per square foot of dwelling unit enclosure area now for attached housing and smaller houses. So that's great. And then the heated garages, there are some exemptions in there on testing for heated garages, as long as you look at the table and do some other things. So some things to be aware of in there. I can't go over them all today. What I really want to go over is this table. This is your roadmap to 3 air changes per hour, and you're so close. This table is, tells us how to do the air barrier and the insulation and each component and where to seal it and where to make sure you get insulation in there. If you do this, you're going to get to that 3 air changes per hour, no problem. And so you do that, and also it says do this plus manufacturer's install instructions. If we tried to make a code with all those install instructions, we would have to carry it around with a wheelbarrow. I mean, like the code would be too big. So it just breaks it up. Here's the places where you need to make sure you seal and make sure some stuff that you need to know about insulation. So I'm just in general, I have to have a continuous air barrier around the entire envelope, and all the joints, the seams, the penetrations, everything has to be sealed. Right? And so I cannot use air permeable insulation to seal things up, right? So I can maybe get away with it in the IRC for my draft stopping or fire blocking, but I cannot use it if I want to pass a blower or to seal up something. It works as a great filter, but it does not work as a great sealant um, to block the transfer of air. It's permeable, right? Here's how this permeable insulation works. This is what I wear in the middle of the winter in Colorado. I wear this fleece jacket. If I put this fleece jacket on, it traps those pockets of air next to me, and uh, it creates R value, right? My body heat is staying in, and I can feel that until the wind blows. Once the wind blows, then I need my windbreaker on. If I put the windbreaker on over the top of my permeable insulation, then now I'm retaining the heat again. It's trapping those pockets of air and keeping them in there, and now it works. This is how insulation works, right? I need my windbreaker over the top of my insulation. Without it, when the wind blows, I feel it and I get cooler, right? This is how insulation works. This is what we're trying to get in our thermal envelope assembly, is that alignment of the insulation and its air barrier so that the insulation has a chance to work. So if that's what it's telling us in the ceilings, it's telling us our air barrier. If I have a drop ceiling, it has to be aligned with the insulation. And then any access openings have to be sealed. And I need to also insulate them. So what this is saying is, I can't just have a cutout of the drywall. And if you looked at how air moves in the building, cold air rises, and as it heats up, it rises, and it's trying to get out any of those openings. And so attic access is a big one. If I turn on a blower door, I'm reversing that, and I'm sucking the air out. If I have a big opening at my attic, I'm going to suck all that volume of attic air in. I'll never pass my blower door. I have to get a tight attic. I can't just cut a piece of drywall and call it good. I need an air sealant, and I need insulation on that. If I have a dropped ceiling, I can put insulation on a dropped ceiling, but I have to have an air barrier for it to count as my towards my thermal envelope. If there's no air barrier, then it's just there for sound. It doesn't get to count. And so I need an air barrier. I can't call the dropped ceiling unless it's a drywall lid. I can't call it my air barrier because it's got a bunch of joints and seams. So I would have to put another air barrier on. But just have to pay attention to that when I'm doing dropped ceilings. Walls, the top of the wall has to be sealed, the bottom of the wall has to be sealed, knee walls need to be sealed. You need to get at least an R3 into those cavities and corners and headers. And then this is where it's really specific to say that the insulation and the air barrier have to be in contact and in continuous alignment with each other in those walls. So if I'm sealing the bottom of the wall, there's a lot of different ways to seal it. I have seen people do caulking. I've seen people use a seal. I don't know. To me, seal is a wicking to keep the moisture from the concrete going up into the wall. I don't know that I would count on it or rely on it as an air sealant. Um, but I see people use all kinds of different things to seal the bottom of the wall. Could I get away with nothing? Possibly. It depends on where you do, how you do everywhere else in your building, right? You are going to decide where in the building you're doing. When you you put your house together, you know, a house gets put together, you do a blower door, you find where the leaks are and which ones you can seal up most cost effectively and easily so that you pass your blower door. Again, we're not trying to say no leaks, we're trying to say very little leaks. Um, and so top of walls, this is one place that's pretty big, people forget about. Um, there, there's no one way, the code doesn't say how to do it, it says to seal it, right? It doesn't say you have to use any particular product or any way of doing it, but the idea is that I seal all of the holes going up into the attic and at the top of the wall so that the attic air doesn't make it into my wall and make it into my house when I do a blower door, or the air that I've already heated and cooled inside doesn't make it into the wall and escape into that attic, and now I have to reheat and recool air all the time. Or the moisture that's in this room doesn't make it in that wall and mess up the wall. Like there's a lot of reasons that we do air sealing. So those are some of the things. Seal up those attic knee walls. Maybe if you put your air barrier where you're supposed to, the insulation would stay where it's supposed to. But there's a lot of times where you have conditioned space and unconditioned space, and that knee wall has to get an air barrier and insulation. It's your vertical envelope wall, right? And so making sure there's some way to get at least an R3 into those corners, redoing how we do those corners. Now that the IRC, in 2021, the IRC made significant changes in the amount of headers that we need. And so it's reduced, which adds to why it's cheaper to build. Actually, in 2018, it made that change. So now we have room to get some insulation up in those headers. So making sure we get insulation in there. Don't use permeable insulation to seal around doors and windows. It works as a great filter, but it will not stop the transfer of air. So using some caulking or some backer rod or something to seal up around those windows. Making sure you get the rim joists for insulation and air sealing. There's a lot of different ways to do it. I see people now just spray foam their rim joists because it's easier than cutting insulation. Making sure you get the floors are getting insulated and the ends of the floors. So especially if I have a garage on one side, I definitely want all of those ends sealed up. I either have to have my insulation in permanent contact with my subfloor, or with the new exceptions that are in the code, I can drop my insulation down. As long as I have some continuous insulation and drywall on the bottom, I seal up my cavities and stuff. So again, I'm barreling through this. Uh, the classes that we're going to bring to you in Nevada will go into detail about how to do all of these things. I'm just telling you, these are the places that we've identified where people are not doing it correctly. So I'm highlighting that. Don't forget cantilevers are floors. There's a couple places that you can get air leakage in a floor and a cantilever. So making sure you get those tight, sealed up correctly. We're finding all kinds of ways that they don't get done correctly. And so getting those sealed up, and then your crawl spaces have to be done correctly with insulation and vapor barriers if they are conditioned crawls. So penetrations, those are things that we found. Your narrow cavities, either fill them with insulation or cut it to fit, don't shove them in there. And then making sure you get that real good separation between the house and the garage. Even if the garage is conditioned, the code says you have to put the thermal air sealing between the house and the garage. We do not want garage air in our house, right? We just don't want that. And so you have to air seal completely. Recessed can lights, that's another place, because that the air is getting warm and it's going up and it's going to try to get out. And so you want to make sure that you have sealed can lights. It's another penetration in the envelope. This is in the table about making sure that you get your insulation If you use permeable insulation, you have to split it around the plumbing, because again, remember it says your air barrier has to be in contact with your insulation. And unless you use like a zip system or something on the outside that can be considered an air barrier, your sheathing isn't an air barrier because you're not sealing all the joints and seams. So you would have to put your air barrier is probably the drywall on the inside. How do you have your insulation in contact with its drywall? You have to split those bats and put them around both sides if you're using that kind of a situation. Air barrier at tubs and showers, making sure that you're getting back there before the tub gets installed and get that air barrier in there. You can come in later and insulate behind it, but you got to get that air barrier in there. That's one place that I see missed a lot, or behind fireplaces. Make sure those electric boxes are filled. That way, if I do get air in that wall from the attic or from the house, it's not going, it can't get, I can't get the air into the house because I'm getting sealed. I'm sealing up all the little holes that would allow that to come in. So there's all kinds of different ways. Every electrical inspector has their way that they want to see it done. So make sure that you are talking to your electrical inspector. This is another place that's kind of crazy to do, but think about it. If I have a register and I have a big floor cavity or a wall cavity or a ceiling cavity and I don't seal around those, when I turn on a blower door, I can pull the air from that cavity and it will add to my volume of air, and I'm not going to pass my blower door test. So making sure I get those sealed up. And then I always say pay attention to all those other places, because it's really hard. If you are required to put fire sprinklers, it's hard to get good air sealing on those sometimes. So because it's not like you can just, seal those plates. And so I pay attention really close to all the other details, because I'm going to have some leakage around this. But it's mostly do it according to manufacturer's install instructions. And then don't forget your ventilation. That's the biggest thing. You're building a tight house, make sure you ventilate it. So here's the other things that we found in Nevada was on whole house mechanical ventilation. Only 50% of the houses had it, and on only half of those you had the right controls. So I know you have amended out blower doors, but that doesn't mean you're not building tight. Just because you don't test doesn't mean you're not building tight. And so you have got to address mechanical ventilation. You have to bring in fresh air to keep condensation down, to allow people to breathe, and to make sure that we are, dealing with off-gassing of furniture and everything else. We need to have fresh air in these at a controlled rate. So working on that and getting the proper controls so that they're running intermittently or continuously or whatever you choose. Duct leakage, we found the average duct leakage was at 3.46, so that's great. We did find a leaky one at 16 CFM, not so great. Low at 0. You believe it? I don't even know how you find a 0 leaky duct, but what we found a lot of the times is that the problem with the test results is you would have been a lot better, but it wasn't sealed at the air handler. The air handlers aren't being sealed correctly, so we're going to look at that in a second. Some other stuff that we found in the South, almost exclusively 80% furnaces were being installed, which is okay because the majority of you are not heating anyway. You're cooling. We'd rather see more efficient cooling. But in the North, you had 92% or better because you are heating more, right? And so that's good. That was great. It was good to track that. That's something DOE doesn't require us to track that we did. In the South, you had 14 SEER air conditioners, in the North, 13 SEER, so that's great. Mostly tankless water heaters in the South, and a mix between tankless and tanked in the North. Just something we tracked, and it's good information to have. But there's some good information out there. If you Google this, nachi.org, air sealing of the cabinet, there's some great places to make sure that you catch on how to get better air sealing at that cabinet. That's where we found the biggest air leakage in these systems. The other thing we tracked was insulation. Insulation in ceilings, overall pretty good installation. The average was only R19. We did find some with no insulation. and the high was R49. So you know, if you guys move to the 21, R49 is required even in climate zone 3, R60 in climate zone up in the north. So something to pay attention to. What are we meeting? The average R19, that just means that remember 71 of those homes used a performance path, or more of them used a performance path. So that just means they traded off. It doesn't mean you're not meeting code. It's just probably it was traded off to a lower amount, meaning you did something better. But it was just saying, I found this a good thing that says, you know, if we did the average R49 that was required, then we could save $1 million a year in energy costs by just going to the R49. That was an interesting amount of money. Above grade walls installed correctly, pretty much. Average R15, just meaning it's traded off again. The low was R13, and you had some that came in at a 20+5. If we met just the basic code requirement prescriptively, we would save $600,000 in energy per year in Nevada. Foundations done pretty well. We didn't find a lot of, problems on foundation insulation, and then you have crawl space insulation, only 50% done correctly, but overall still only 9,000 between both of them in savings. Not say only, that's still an amount of savings that we could see, but where we're going to put our focus, right? And then windows, right? You're doing great on windows. The U factor requirement is 0.32 in the south and 0.30 in the north. Here are averages that we saw. They were all better than code, or mostly better than code. Your low and your average were the same, so that's great. We saw a couple non-compliant, but you're doing great on windows. It's your solar heat gain in the south that's big. The north is throwing you off because there was no requirement, and so it added to that average. But you're still doing pretty good in this. It's probably a higher savings if we just looked at the south by itself. This number would be more, but so we're looking good, Nevada. It's attention to detail. Performance and production builders, people using the performance path and production builders are struggling less than prescriptive or custom builders. Pay attention to those details in the thermal envelope, all those assembly layers, how to get them all. Pay attention to your mechanical ventilation and the strategies. Identify the thermal envelope and seal that air handler. And that's what we found in Nevada. I'm a little bit over, so I'm going to go to questions.
Super. Thank you so much, Shaunna. We really appreciate just the
incredible. A lot of info, sorry.
No, that was great. Because we are so short on time, I have 2 questions that I'm going to ask to you before we wrap it up.
Okay.
The first one is from one of the audience members who asks, it is my understanding that the 2021 IECC requires duct testing in all compliance paths, regardless of duct location, except for the total building performance path. Is that correct?
So duct testing has always been mandatory. You always have to test no matter which path. That's 100% true. That it's always been that way. No matter which path, you have to test your ducts. And then there was always an exception. You don't have to test as long as you are inside the thermal envelope. The only change in the 2021 is that now you have to test all ducts, whether they're inside or outside the envelope. So duct testing has been one of those mandatory items. It's not something you could trade off. You can trade off the amount of leakage. So if you were required 4 CFM prescriptively, you can trade off to 3 CFM and use that as a deposit because you did better than code, or you could trade off worse and use that as a withdrawal because you did worse than code. You can trade off the amount, but you have to test.
Great, thank you. Is there any inclusion for indoor air quality, either in the prescriptive or required pathways?
Yeah, indoor air quality is one of the reasons that we are doing that building air tightness, right? We build a tight envelope so that we don't get in all of those allergens and any smoke or dirt or whatever from outside. And then we bring in a very controlled amount of fresh air to deal with condensation and fresh air to breathe and things. And so one of those, yes, that's so that we don't have to reheat and recool new air all the time with that leakage, but it's also to reduce the amount of things that come in. The amount of fresh air we bring in deals with the off-gassing of our furniture and stuff so that we have fresh air to breathe, but it's at a controlled amount. So just about everything in the thermal envelope requirements for air sealing go to indoor air quality.
Super, thank you. And I'm actually going to slip in one more question, and that is there a yearly comparison in total energy usage from Code Edition to Code Edition?
Yes, absolutely. So the Department of Energy, at that same website, energycodes.gov is an amazing website. That's where you download ResCheck or ComCheck, or you can use ResCheck, ComCheck online. It has a great resource center. But it's also got on there the Department of Energy. Every time a code gets printed, they go in and do an analysis, and so does the National Association of Home Builders. I like to kind of compare them side by side to see how they do their analysis, but they both will do an analysis on the cost and the savings from each edition to the next. And so that's done they do it at the national level for the overall code, and then they will go in and analyze it for each state based on what climate zones. So you can see the cost jump or the savings increase from code edition to code editions for your climate zone or for national.
Super. Thank you so much, Shaunna. And we did receive a few questions about the recording of this webinar. So just to confirm, we will have the recording of this webinar available for anyone that has registered for the webinar. You will receive an auto email with that link to the recording. So look for that in the next few days. So Shaunna, I don't see any other questions. So thank you so much for sharing your time and your knowledge with us today. Thank you to our audience for attending and asking a few great questions. And thank you so much to PowerShift by NV Energy for their generous sponsorship of this webinar. Please join us for our next webinar on June 14th at 2 o'clock Eastern Time with Leslie Adkins, Vice President of Marketing and ESG Development at Trex Company. And that webinar will focus on the impact of outdoor spaces on well-being and sustainable living. And it'll focus on outdoor settings and how they impact human beings in terms of mental health, physical health, and it'll also highlight tips for creating an eco-friendly outdoor living space that brings harmony between home and nature. And then after that, our next webinar will be on Wednesday, June 28th, at 2 o'clock Eastern, presented by Josh Christensen, the CEO of Home Technology Association, on how builders can meet their clients' technology expectations. And Josh will share best practices on getting smart home technology right. So again, thank you all to everyone. Thank you, Shaunna, and thank you to NV Energy. And that's a wrap today. Okay, bye-bye.